Hello everyone, this is Said from Embedonics, and today we are going to talk about how to emulate Raspberry Pi on Linux distribution. So as you can see here, I have Kubuntu. I don't know the version, I think it's 15.5 or something, but it doesn't matter. This procedure will work for almost all, at least Debian based distros. So to emulate Raspberry Pi on Linux, you need three things. The first thing is that the image of the Raspberry Pi that you can easily get from the raspberrypi.org website. I'm here at the moment, so I'm going to downloads, and I haven't tried this procedure with the Noobs distribution. I'm going to choose Raspbian one, and from the Raspbian there are currently two flavors, I guess, and I haven't tested with JC, but I think it would work, but I would recommend you to do this for VZ. So all you need to do here is to download the zip file, and it will be a file around 900 megabytes in an archive, in a zip file, as I said. And after that, you just easily open up your terminal, any terminal that you like. In my case is Quake. Yeah, my terminal was Quake. Yeah. Okay, I'm going to my download folder and the listing, and I have already downloaded this file. So let me go back to my home directory. I want to do this stuff in my working directory, you know, just to have a good kind of folder structure, so to say, speak. And here I will make a folder like okay, Raspberry Pi, just for fun. Going inside this folder, then I will move this zip file that I downloaded to this folder. Okay, now I'm going to unzip it. Okay, while it's going to be unzipped, I want to tell you about QEMU. QEMU is a CPU or architecture emulator. You have probably heard about it. So to be able to emulate Raspberry Pi, you really need this QEMU. And let me open up a new terminal. I have already installed this. I'm going to check it if it's working fine. Okay, I have QEMU. What we need is ARM. QEMU ARM. Okay, we have it. Anyway, if you do not have QEMU, the installation is quite easy. Either, if you feel you are very pro, you can go to QEMU and build it from the source. And if you feel like me, a bit lazy, or do not know how to compile complex stuff, all you need to do in, at least in the Ubuntu, is to write apt-get install QEMU-system-x86. I don't really recommend you to get the 64-bit version because it has some problems. Let's go with this one. Enter your password. Make sure your password is correct. Really? What happened to my password? Okay. I think there were some new updates for this, so I'm going to install it anyway. So let's check if our Raspberry image has been decompressed. Yes. Okay, let me clear. And for the sake of visibility, I'm going to minimize the browser. So let's see what we have here. We have an uncompressed image and the original zip file. I advise you to keep the original zip file in place, because maybe you do something wrong and you have to download the whole 1 GB of data again. So I'm just gonna rename it. The zip one, I say RPI dot RPI dash backup dot zip, and I'm gonna rename the other the compressed image to an easier name, RPI dot image, because you're gonna type this a lot, so you want it to have a very short name. Sorry. Okay. Yes. So let's check our QEMU installation been installed. So I do a QEMU-CPU. No. Okay. Anyway, it's gonna work. No worries. If you had any problem with installing QEMU, you can ask it on the Ask Ubuntu forum, or you can put a comment on my video, so I will try to help you out. Anyway, the next thing you need is actually a working kernel of Raspberry Pi or Linux, so to speak, that is compatible with QEMU. So for this one, a nice guy has already compiled this, and it is available on GitHub. I will paste the link in the description of the video in case you cannot copy it from here, and you probably wouldn't. So all I need to do now is to go back to my terminal, and let's clone this this kernel. Okay, it's getting done. Less. Okay, now we have a folder called oh, we don't have tree. Okay. So we have a folder that contains the kernel. We have a backup of our original Raspberry Pi image, and we have RPI image itself. And let's start doing some actual work in a moment. So we are back in our working directory. That was or your home directory. In my case, work, then Raspberry Pi directory. You can have this directory anywhere that would you like, but this is my personal preferences. Okay. So we have, as I said, we have the kernel folder that contains the kernel, the image backup, and the image itself. So we're gonna do some bash scripting now. I want to make a script that lets us configure our Raspberry Pi emulator. So I'm going to say, let's try with Kate editor config. And all you need to do is to, well, first you need to give the directive to the bash, /bin/bash. This line is very important. Let me make it bigger. Then this will be your comment. This is script configs Raspberry image for initial setup. And what you need to do is simply paste in this text that will run this command, and you need to do some changes. And this will use the QEMU, the ARM system, and this dash kernel switch will tell where the kernel actually exists. In our case, cd. In our case, it's here, /home/work, and the folder that we have cloned from the GitHub. So I'm going to copy this here using Ctrl-Shift-C to copy from a terminal, and I will replace it here, and slash again kernel dash what was the name? Kernel QEMU. Okay. And because it's going to be a relative path, I'm going to say dot slash. It refers to the current directory, because we, as you saw, we're going to call it from the root working directory of our emulator. Okay, the next thing you want to change is the name of your image. It's by the switch-hda. If you remember, we renamed our image to rpi.image. Okay, rpi. Don't worry, guys, I will paste this in the video description, or I will put it in a paste bin or somewhere that you can easily copy and paste, and it will hopefully work for you. Okay, now I have saved this, and let's see if it's saved. Cat config. Yes, it's there. We have to make it executable by using chmod or change mode plus x config. So hopefully when we run this, we will be booted into Raspberry Pi. So let's hope for the best. I will execute the script, and yes, we're in like Flynn. This is our Raspberry Pi. Well, at least we have to configure it from here. So let me show you some hints. When you put your mouse here, the mouse will be captured in the screen. If you want to get out of it, you have to press the left control and left alt together. Then you will have your mouse back. And now we have to make some changes in the Raspberry Pi configuration, and that will be changing the way that the Raspberry Pi looks to inflate the image that it has. So for that, we're gonna go to the internal editor of Raspberry Pi, in this case Nano. I will write nano /etc/ld.so.preload. So we have to comment this out, and how we do it? By putting a hash in the front of the line. Then we save it. In the Nano, the saving is done by left Control O. It will overwrite the file. Then Control X will exit. Okay, the next thing is you have to, because the Raspberry Pi by default, it tries to read the data from a SD card. You have to redirect it to the path that you gave it to in your script. I will show you later, but for now you have to go to edit this using Nano again. Nano /etc/udef, then rules.d, then you have to make a new file, name it like 90 or QEMU dash rules. Okay, so we have created a new file, and we want to introduce some new rules for the USB devices. And what we need to do here, we have to put these lines: kernel equals SDA, comma, symlinks plus equal MMC black 0, MMC black 0, and I'm going to a new line, say kernel equals SDA question mark, comma, symlinks plus equal MMC PLK standing for black 0% 0 P% N, and the last one will be kernel equals SDA2 symlinks plus equal root. And I will tell you what this does, because in our script we told the QEMU to make a kind of a temporary storage device called SDA, and here we're gonna so to speak forward it to replace the, if for example Raspberry Pi tries to read something from MMC block 0, which it does by default if you have a real one. In this case it goes and reads from SDA, and other things will be replaced by for example the root will be pointing to SDA2. Anyway, it doesn't matter. Just make this file, write it, make sure to write it, then exit. Then I think you are done with the basic configuration. So after this, you're gonna power off your Raspberry Pi by sudo shutdown now. Okay. Anyway, just close it. Yes. Now we need another script. For making this, I'm gonna copy our config script to a new file, call it runme. Okay. Now I'm going to edit this runme file. And this is what I told you about the redirecting the SD card to the SDA that the QEMU temporary builds for us. Okay. Now the changes that we have to make is we have this QEMU-ARM system, then we have the kernel, we redirecting to the kernel that we downloaded, the CPU, the memory. It is important that you never change this 256. Don't be tempted to make, for example, 512, because the amount of memory is hard-coded in the Raspberry Pi kernel, sorry, and it would not work with any larger than 256 megabytes. Okay. Then we have the serial, stdio. Yep. This is fine. We close this. Now we say run me. Okay. And hopefully this time it can get the SD card. No, we have some problems here. Let's see what the problem is. Okay. Let's try again. Kate, run me. I think we have to change some stuff here. I will just put the other link here. Again, the changes that we need, the run me script should be different with the config script, and the first thing is to correct this, then the CPU, and everything's fine. You just need to run this one, Okay. Okay. The difference was that for the running we do not need this. Anyway, I'm going to save this, and hopefully this time we can actually run it. Okay. Yes, it seems to be working okay. And in a minute we can have a serial console to our Raspberry Pi. Because I don't like to work in this small screen, I will just minimize it and I will wait for the login to pop up here. Let's see, and it's actually a bit slower if you compare it with a real Raspberry Pi, but that's what you get for emulating. But there are some tricks that you can do to make it work faster, and I believe it's running it on a static mode with QEMU. At the moment we are running this emulation with system emulation, but if you do it at the user or a static level, it will be much faster. Anyway, we are in the familiar page for many of you Raspberry Pi lovers. Expanding file system. Let's try it. We don't need it. Change user password. We don't need it, and everything seems to be fine. Let's me overclock to the maximum. And beware that it is Raspberry Pi 1, not 2. And another thing you want to do is to change the keyboard. The local we don't need, locale we don't need, but anyway, let's try it out. Okay, let's cancel. The only thing is the keyboard. I want my keyboard to be United States International, so I have the Alt Grand key combinations. Okay. Okay. Let's find the 105 keys. The standard keyboard. IBM. Okay, generic 104 keys PC international. Let's try this, and let's put the layout to United States. English, United States. Then the layout for me, at least, will be use international with Alt Grand dead keys. Okay, and my right Alt will be this. Compose key. Yes. Now it reloads the key map. And after this, I want to show you that how you can grow up the available space on your image, because at the moment you by default you only have 200 megabytes of extra space. So I'm going to finish this setup, and I go to reboot. We are waiting for the Raspberry Pi to be rebooted. And the next time we're just gonna use our own terminal for the interaction with the Raspberry Pi. So I'm going to minimize this and wait for the login prompt to be here. because we have forwarded the serial to this QEMU instance. Sorry for the long delays. That's not something I can do. Is it still trying? Come on, man. We're almost there. Okay, we are at the login prompt, and this time I'm going to use my lovely Quake terminal. Okay, I'm logging with username P, and the password, all you Raspberry Pi fans know that the default password is raspberry. Okay, clear. Now we are in like Flynn, so let's make it less. We are in the home directory, there's nothing interesting there. Okay, I want to check how much free space I have. df -h. So it says that on my root file system I have 335 megabytes available, and that's not something you want to have. And in the next video I will show you how to resize this, and yeah, hope it works for you, and make sure to subscribe and all those kind of stuff. See you.